talking about growth of populations. Okay, talked about exponential, logistic growth. Organisms in an environment are going to grow and reproduce and multiply until they reach a certain point where what runs out? It's a word up there. It's listed up there several times. Until what runs out? Resources. They're going to hit a point to where the resources available can only support a certain number of organisms. Then things are going to die or they're going to stop reproducing. Okay? So what determines that point are called these factors, limiting factors. Okay? These things limit the growth of a population. We talked about density and carrying capacity the other day. We're going to hit them again. All right? Population density, the amount of organisms in a certain area. Like I said, with this room, there's about 30 of you in here. It's comfortable right now. If I put 60 more people in this room with you, would it be comfortable? Yes. I mean, you'd be packed in here, especially if the air wasn't working like yesterday. It would be nice and nasty in here. All right? Not comfortable. The environment's not suited for that. Same thing happens in the natural world. Okay? Carrying capacity, the maximum amount of individuals that the resources can support. All right? We get too many, what's going to happen? If this section of land can only support 5 lions and we have 10 living there, what's going to happen? There's a C word. It's that C word that's going to happen between those 10 lions. What? Somebody said it. Competition's going to happen and 5 of them are going to do what? They're either going to move or they're going to die. All right, because the land can only support that many. We call these things limiting factors. Something that keeps the size of the population down or keeps it limited. All right. So, limiting factors. We have density-dependent limiting factors. This goes back to that population density affected by the number of individuals. Okay. We've said competition. Predation, remember what that is? Hunt, kill, and eat. That's going to limit how many things grow there or survive there. Parasitism, I don't know why competition's on there twice, but it is. Probably because it's important. And disease. If you have a disease come through and it only affects deer and it wipes out the deer population, and the deer is the main food source of it's going to decrease, all right? So all these things work together. They're not separate things. They all affect everything, okay? So density independent limits a population's growth regardless of density. Weather can do that. When the hurricane comes through, does it change things? Does it change the environment? Can the same organisms survive there that they did before? If a tornado comes through, tears out all the trees in a 1 mile width, a bird's going to be able to live there anymore? All right, so that changes what's there. So weather, natural disasters, and then of course us. We talked about the woodlands, how it used to be, all this used to be trees. We come through, we take them down, we put concrete in, buildings in. Does it change the environment? Yes. Change what can live there, okay? The amount of organisms and which organisms can live there, okay? This stuff, dependent, happens within the organisms. This, independent, is something else occurring that they have no control over. All right? Did the animals that used to live here have any control over the humans that came in and wiped out the... No. All right? They had no control over that. Questions about limiting factors? All right, succession. Succession's a big thing with ecology. How all of this stuff comes about. How communities are born, how populations come in, how biomes form, all is succession. All right? We have 2 forms of succession. You see them both here, and we'll talk about both of them as we go today. So, succession happens after a disturbance. Talking about that tornado, that hurricane. We have a volcano. All right. These two pictures are of the same area. Volcano erupted. This is what it looked like years later. Does it look the same anymore? You can tell where the volcano was, the lava flow was, but does it grow back? Really? I see grasses, I see plants. It grows back. All right. Succession regenerates or recreates a community after a disturbance. When we had the drought here a few years ago, we had a lot of forest fires. To be honest, it was a bad thing. It was very bad. Go down to Bastrop State Park, it was completely burnt. Nothing left but a few burnt sticks sticking up out of the ground. But that's one of the best things for that environment. Because when you burn all that stuff, we talked about this the other day, what does it put back into the environment? Yeah, carbon, nitrogen, puts all that stuff back in. It is very green, lush, trees growing, everything now. Because it made it very fertile so we could have succession happen. Okay? The first species that moves into a new area is called the pioneer species. Think about history, talk about pioneers. There's people who discover new lands. That's how we name them pioneer species, the first organism to move in. Once it's all back to the way it should be, we call that a climax community. Climax meaning the top. Can't get any better than this. Okay? So here's the disaster up here in the top picture. Here's the climax community years later. Now you have to think about it. It's not an overnight thing. It takes years for this to happen. It takes tens of years for trees to grow. Because trees don't grow very fast. Okay? So the first type, primary succession. This is think about when the earth was first formed. There was nothing here. This was just a huge chunk of rock. And that's it. All right? Is it that way now? No. We had primary succession. Started with bare rock. We had to have one species of organism come in, establish itself there, and everything starts from that. Okay? Those pioneer species are usually things like lichens and moss. The reason why is because they can get nutrients out of rocks. What did we say was in rocks? Phosphorus, carbon, so some carbon in there, some nitrogen in there. Those things like lichens and moss will break down that rock and they get their nutrients. Okay? Well, then other things develop from them and we keep moving forward. All right? Secondary succession is after that major event. Talked about the forest fire. That's all gone. It burns everything off. It goes back to just soil and that's it. All right? Plants are going to start to grow there. And then once one plant grows, we have that buildup. Okay? How would those plants get there? Any idea how those first plants could get there? Oh, there's nothing there but soil. Bare soil. How can them plants get there? Keep that in mind when we start looking at how that stuff happens. All right? There's different ways for that to happen. So succession. Communities have the most biodiversity during intermediate stages. All right. When they reach a climax community, only the most fit will survive. So I'm going to go back one screen. I'll come back to this. So if we look at this picture here, we have beginning, not very diverse. There's nothing here but soil. We have intermediate here in the middle. And you notice you have 1, 2, 3, 4, 5. You have a bunch of different organisms. It's most diverse in the middle because everything's trying to grow there. We got all these different, all this new stuff. Everything wants to grow there, but eventually, what happens? The ones that are suited survive. Are any of these small shrubs and bushes left here at the end? No, why can't they survive? Look at what's there, and then why can't these guys survive in this environment? Yeah, because they grow on the ground. What's going to not be there now? Say that again. Sunlight, because the big trees take over. All right, so you're most diverse in the intermediate, in the middle.